Hello everyone and welcome back to the Invent Academy. My name is Radu and today is a very exciting day for all of you OnShape lovers because for the first time we get to use what we learn in the 2D tools and 3D tools tutorials to build something. And to be more precise, drumroll please, we'll be building a Lego brick. Isn't this exciting? If you're anything like I was when I was a kid, I used to love Lego. There was no better gift to get other than a Lego brick. And I found this diagram online, and as we build it, I will walk you through the process that I normally follow when I decide how to build something in OnShape. These are all the dimensions we have for the Lego brick in millimeters. And before we go ahead and start working in OnShape, let's talk a bit about how we're going to approach this. The way we try to do this is we try to start with a 2D drawing with a sketch that's on a plane, and then we think about operations we can do to a sketch to obtain some of these features. The simplest operation of all is extrusions. Extruding, there's no thing you build on CAD that doesn't have extrusions on it. Extrusions are everywhere. And as you can expect, it is very easy to use extrusions to build this Lego brick. The face that I would start working with is probably the top face, because we can draw a lot of these features on here and then we can extrude them. For example, we can extrude the walls downward, we can extrude the pegs upward. Very similarly, you could start with the bottom over here, and with the pegs extruded, you can also put the walls in and extrude those too. So both of those are very valid choices. As I've said before, there's no single way to do something in CAD. My question to you is, would choosing the side be a good choice? Do you think that, for example, if we choose this perspective or this perspective, would we be able to build the Lego brick this way? It's definitely worth a try. However, due to the fact that we have these dimples on it as well as the walls, it would definitely be a very weird choice to make because you cannot really extrude anything into the page or out of the page from either of these views to create the brick. Whereas from this view, it makes a lot of sense to put these pegs on and to put the walls on and so on and so forth. So let's start working in OnShape. I'll go ahead and click on Create, click on Document, and say Lego brick. And I'll call it a 4x2 because it has 4 pegs by 2 pegs in the X and Y directions respectively. Of course, I don't really need to mention, but for you to be successful in this tutorial, it is really important that you follow and understand the 2D and 3D tutorials that we have previously made on the Invent Academy. You don't have to be an expert in it because this is what comes with practice, and this is what we're trying to do with the Lego brick, for example. However, you do need to understand the basics before you are able to attempt this tutorial. Now, let's start by creating the top view. We'll start with the rectangle on the top plane. I'll therefore right-click on the top plane and say New Sketch. Next, I'll go ahead and click on the top of the view cube so I can normal to it. The size of the outside of the brick is 15.8 millimeters by 31.8 millimeters. Let's put this in. I will select the center rectangle and anchor its center in the middle of the plane. You will see why very soon. Next, I'll go ahead and click on Dimension up here and put in my dimensions. Oops, sorry. Perfect. So 31.8 for the length, and then 15.8 for the height. Next, what I will have to do is put the walls in. Even though the walls are not really visible from the top, we do know that walls go into the page from this top view of ours. So it would make a lot of sense for us to draw the walls in this view and then to extrude them downwards into the page or into the screen. Let's see how thick the walls are. It appears from this view over here that all walls are 1.2 millimeters thick, which is exactly what this dimension here shows us. Let's return and then select another rectangle, anchor it in the center, and then extrude it, not extrude it, but extend it outward. Now, we pick the dimension tool, but instead of dimensioning an edge, what we'll be dimensioning is the distance between these two lines, 1.2 millimeters, and we'll hit enter. Now, you'll see that the only thing you can change on this rectangle is this length here because we haven't defined it. Anything else is fully constrained. When something is fully constrained and it cannot be moved in OnShape, it turns black. However, because these two vertical lines can still be moved, they are still blue. We now need to make this distance here equal to 1.2 millimeters too. So we select the first edge. OnShape gives us the option to select the length for this. We don't want that. We now click on the second edge and we type 1.2 and hit enter. There we go. The reason I selected the center rectangle becomes obvious now. It's because the rectangle is symmetric about the vertical and the horizontal axis when you select the center point variant. Therefore, this distance here, 1.2 millimeters, is also copied for over here, while this distance here is also copied over here on the right-hand side. Therefore, we need to work less, and as engineers, we love working less and finding quick ways around things. The next thing we have to do is we have to put in a dimple, or one of these pegs as they call them in Lego. The size, the diameter of this peg, appears to be 4.8 millimeters. The way you know this sign over here, the O with a vertical line through it, means diameter. Therefore, I will create a circle which is 4.8 millimeters big. I'll click on the center point circle, put it anywhere at this point, extend it outward, and then I will click on dimension. And how much did we say? 4.8 millimeters. Perfect. Now, as you can see, this circle is free to move around. However, with Lego, we know exactly where this circle has to be. So let's return to our drawing and you will see that the circle, for example, is 3.9 millimeters away from the shorter edge. So let's go ahead and position our circle over here, select the dimension feature, and we know that the dimension between the center of the circle, so I click on the center of the circle, and the rightmost edge is 3.9 millimeters. So I type 3.9 and hit enter. There we go. Now, let's find the dimension between the center of the circle and the top line. As I try to move the circle around, you will see that it can only move vertically because horizontally it is restrained to be 3.9 millimeters away from the right edge. How do they do this? Because here they gave it to us explicitly. They said it's 3.9 from the center to the edge. However, vertically, they don't do that. However, they do say that there's 8 millimeters between the center of this peg and the center of this peg. And we know that the pegs are symmetric about the horizontal axis. Therefore, the distance between this peg and over here, the top line, is equal to the distance between the center of this peg and the bottom line. So if we subtract 8 from 15.8 and divide by 2, we should be able to obtain the right result. Let's see, let's hit up Google and hit enter. As you can see, when you use CAD, it is not just geometry that you have to use. You have to use arithmetics, as well as later you'll see that trigonometry can sometimes be very useful too. You use your whole understanding of mathematics when you use CAD, which is what I love it so much. You will see that the result is 3.9 millimeters, which, if you follow through, you'll notice it is as big as the distance between the peg and the right edge. And as you can see, it kind of looks like it is symmetrically positioned from the two edges, which makes sense. However, now we've also proven that mathematically. I'll select the center, I'll select the top edge, and then I'll click 3.9. Click enter. Perfect. Let's click on this and take a look at our sketch. It looks great. What we have to do now is add 7 more pegs. How are we going to do this? Well, you've seen what the size of one is, and you know how far apart from each other they are, so theoretically, you could just keep making circles in OnShape. However, us engineers, as I've said before, always try to use easier methods. And believe it or not, there is a very easy method using the linear pattern, which is exactly what this is for creating patterns of repeating items. And if you hover over it, it actually tells you how you're supposed to use it. It tells you what it does, and then it gives you the instructions. The linear pattern tool lets you create multiple instances of sketch entities uniformly in one or two directions, which is exactly what we want. We'll be doing it in two directions, both on the x-axis, which is to the left, and in the y-axis, which is down. So first we need to select the tool. I'll press on it. Select the entities to pattern, which in our case the entity we're trying to pattern is the circle. Then specify the number of instances in one or both directions. For us, we want 4 pegs in the x direction and 2 pegs in the y direction, and then drag the linear arrows or enter a distance value. Let's see. I will first click on it, which is what they tell me to do. Then I need to, they've already created 2 for me. Oh, they've created more for me. Okay. They've created 3. However, in the x direction, I want 4. So I click on this and say 4, click enter, and then I get a chance to set the distance between 2 of them, which in this case is 8 millimeters, as you recall. And then instead of making them go in the right direction, I want them to go in the left direction. So I will just press on this arrow over here. Perfect. I now have all the circles in the x direction. Let's figure out how we can make the circles in the y direction. You will have to find this arrow over here, which asks you how many lines you want in the y direction. In this case, we want 2 lines, so instead of 1, we double click, we type 2, and we press enter. Once again, you get a choice of the distance between the lines, which from the drawing we know is equal to 8 millimeters. We type in 8 millimeters and we press enter. Last but not least, before we finish, we want to make this go downward. So we press down. Perfect. And we press enter and save. There we go. Even though we only have a sketch, as you can see, there is nothing 3D about our geometry so far. It is a simple drawing. I can assure you that within the next 4 minutes, our Lego brick will start to catch shape, and you will be so impressed with your own results. Let's start by creating the walls. I will go ahead and select the Extrude tool. Now, I will press on the exterior boundary, which is this one over here. Let's go back and see how tall the Lego brick is. It tells us very simply that the Lego brick is from its top plane, which is this what thing here that we drew, to the bottom, it is 9.6 centimeters. Perfect. 9.6 millimeters, I'm sorry. Therefore, over here, where it says depth, I will type 9.6 millimeters and press enter. However, instead of making it go upward, I want it to go downward so that we mimic the drawing and it all makes sense. Therefore, I press on the arrow and now it's been extruded downward. Perfect. Exit. The next thing I want to do is you've seen that after I've made the extrusion, the sketch I used has been hidden. Therefore, I can press on the sketch. Oh, what did I do? Ugh. Come on. What's going on? There we go. Show sketch. And now we can see the sketch again. Perfect. The next thing we need to do is make the bottom of the brick. By bottom, I actually mean the top surface. This thing here, what connects all the dots together and connects the wall to the dots. This part. As you can see, even though it has some holes in it, I would start by considering it a flat thing and then making it 1 millimeter thick. Let's go back to our block, and as I've said, we'll select this whole plane and then extrude it. So I'll press on extrude, make sure solid is selected. However, now instead of saying new, I will select add because we're trying to add to the same brick. We're still adding material to this brick. We're not done with it. I will now click on this part and keep adding because we don't only want to add the middle part, we also want to add the circles. You will see why. And now I will say 1 millimeter. And instead of adding material upward, I'll be adding material downward. Perfect. If we hide the sketch, you'll start to see that our Lego brick is starting to take shape. It is empty on the bottom, as I've promised. Perfect. And from the top, we are almost ready to add the distinctive Lego pegs. Let's return to the top view. Actually, let's use an isometric view for this. Perfect. And then show the sketch again. I'll click on the sketch and click on the eye to show it again. And let's return to our drawing and see how tall the pegs are. The pegs, it appears, are 1.8 millimeters tall from the surface, from the top of our block. Therefore, I'll go back and I'll hit extrude again. I will click on all 8 of my circles. 1, 2, 3, 4, 5, 6, 7, 8. And I will say 1.8 millimeters and press enter. Look at this. Doesn't this look like such a great Lego brick? Perfect. I will hide the right plane too. Oh my God. Congratulations. You are almost done building a Lego brick. This hasn't been an easy project, but you have succeeded. As you can see, there is a wall, a top part on the Lego brick, as well as the distinctive 2x4 pattern on top of the Lego brick. Before I leave you, I want to show you how to add another feature, And then I will let you finish this brick by yourself by adding these interior webs. We will add together the last 8 little holes that go inside of the Lego brick. And then I will let you add these features by yourself, these webs that help the Lego brick connect to other Lego bricks. To add the dimples, we will go to the bottom view, perfect, and we will start sketching on the bottom surface, which is this one over here. So this is an actual surface of a 3D object. We're not on the same sketch anymore. Therefore, I will right click on it and say New Sketch. And now, let's see how big those small circles are. They appear to be 2.6 millimeters in diameter, so I will make one circle that is 2.6 millimeters in diameter. I'll click on dimension, 2.6 millimeters, and hit enter. Perfect. And now we need to make the observation that all of these little circles are centered inside the big pegs that we just made. What does this mean? This means that under each of these lies a concentric little circle. So inside this circle lies a small circle with the same center as this circle. And so does for all of these other circles, other pegs. What this means is that the distance between any of these two and the walls is identical as it was for these small interior pegs. Therefore, if I go back and I hit dimension, I can dimension the distance between the center of this and this edge to be 3.9 millimeters. And you can hit again and say 3.9 millimeters over here. Perfect. Oh, yes, there we go. And now we will use the same sketch pattern to create the other 7. So I'll go ahead and deselect dimension, select pattern, select the circle, and then instead of saying 25, I will say 8 millimeters. I want 4 of them. Press enter. And now in the Y direction, I want 2 rows. So I press 2 and click enter. And now instead of them being 25 millimeters apart, I want the rows to be 8 millimeters apart. And now I can press enter again to confirm. Would you look at this? Beautiful. Now, if I exit the sketch, you will see that inside our block, there is a tiny little sketch that has all of these pegs inside. Let's see how deep these cuts have to be. Over here, you will see that while the top peg extends 1.8 millimeters upward, the inward holes extend 1.7 millimeter upward. So what I will do is I will go to the bottom feature, then click on Extrude, make sure solid is selected, but now instead of saying new or add, we're trying to take material away. Therefore, I will select the remove option. I will move the menu away so that I can start selecting my circles. Perfect. And now the depth, as I've said, is 1.7 millimeters. However, before I make it, I need to check that OnShape is creating the holes in the right direction. In this case, they're creating it upward toward the top of the brick, which it is. Therefore, I will click on the green check mark to confirm what I've just done. Look at this. Now, the bottom of our brick has these 8 little holes, while on the top, you'd have no idea that is the case because they do not penetrate all the way through. This is the beginning of how to create a Lego block. You are almost done, and I definitely recommend that you continue. The next thing you need to do is incorporate these features over here. There's these 3 cylinders that need to be added, 1, 2, 3, as well as these 2 vertical webs, which are better viewed from these angles, these 2 guys, as well as these tiny connections on the sides. I will let you figure out for yourself how to construct these, and as always, if you have any questions, do not hesitate to reach out. Once again, thank you for joining us today on the Invent Academy, and we wish you a great time exploring OnShape. Bye!